Tu-160 Strategic Bomber Modernization. Tu-160 Missile Carrier Bomber, NATO Codification, Blackjack, is designed to destroy targets in remote geographic areas and deep in the rear of continental theaters of operations. It is the largest supersonic aircraft and variable geometry wing aircraft in the history of military aviation, as well as the world's heaviest combat aircraft, having the highest gross takeoff weight among bombers. For its power and grace, Tu-160 was unofficially named White Swan. Tu-160 was initiated in 1975 as a counter to the American Rockwell B-1 Lancer, entering service in 1987. It was primarily engineered for delivering nuclear and conventional payloads deep within enemy territories. Its design allows for a heavy payload and long-range missions, supported by 4 Kuznetsov Nk-32 afterburning turbofan engines, contributing to its extended range of 12,300 km without in-flight refueling. The aircraft's design, including its variable geometry wing, is tailored to enhance its performance across different flight speeds and altitudes. It is also equipped to carry strategic cruise missiles such as the Kh-55MS, which have a range of up to 3,000 kilometers. The Tupolev Tu-160 is designed to accommodate a crew of 4, including a pilot, co-pilot, bombardier, and defensive systems officer. The aircraft's dimensions are notable, with a length of 54.1 meters, a variable wingspan of 55.7 meters when the wings are spread at a 20-degree angle, and 35.6 meters when swept to a 65-degree angle. The height of the Tu-160 is recorded at 13.1 meters. Depending on the wing configuration, the wing area varies between 400 square meters when the wings are spread and 360 square meters when they are swept. The empty weight of the aircraft is 110,000 kilograms, with a gross weight of 267,600 kilograms and a maximum takeoff weight of 275,000 kilograms. It is powered by 4 Kuznetsov Nk-32 afterburning turbofan engines, each providing a thrust of 137.3 knots in dry condition and 245 knots with afterburner. Regarding performance, the Tu-160 can achieve a maximum speed of 220 km per hour at an altitude of 12,200 meters, corresponding to Mach 2.05, and maintain a cruise speed of 960 km per hour at subsonic speeds, Mach 0.9. Its practical range without in-flight refueling is 12,300 km, based on flying at Mach 0.77, while its service ceiling reaches 16,000 meters. The combat range varies, with the capability to reach up to 2,000 km at Mach 1.5 or up to 7,300 km at subsonic speeds. In terms of armament, the Tu-160 is equipped with 2 internal weapon bays that can support up to 45,000 kilograms of ordnance. This includes the capacity for 2 internal rotary launchers, each capable of holding 6 Raduga Kh-55SM/101/102/555/BD cruise missiles, which constitute the bomber's primary armament, or 12 Raduga Kh-15 short-range nuclear missiles. In recent years, the Russian military has been updating its strategic bomber fleet, which includes the Tu-160. This modernization effort began following a 2015 directive from Putin and aims to improve the aircraft's avionics, radar, and navigation systems, along with integrating new weapon systems. The decision to resume production of the Tu-160 in its updated form, the Tu-160M, reflects a step in advancing Russia's military aviation capabilities. This program led to the first flight of a newly produced Tu-160M bomber on January 12, 2022. There are plans to bring all existing Tu-160 bombers to this new standard, with a further updated variant, the Tu-160M2, planned for the future. This modernization fills a temporary gap pending the arrival of the next-generation promising long-range aviation complex, PAC-DA, expected to be in service by approximately 2027. The PAC-DA is intended to replace older models such as the Tu-95, Tu-160, and Tu-22M3. Currently, there are 14 Tu-160 strategic bombers in operation within the Russian aerospace forces, each bearing unique designations. The resumption of Tu-160M production, notably under challenging conditions due to sanctions, required significant efforts in digitization of design documentation and restoration of technological processes, including vacuum welding for titanium components and the production of aircraft airframe units, as highlighted by Sergei Kamazov, General Director of the Rostec State Corporation. Key enhancements to the Tu-160M include upgrades to its onboard electronic systems, including updates to the inertial navigation, electronic warfare, fuel management, and weapons control systems. Additionally, the aircraft may be equipped with updated Kuznetsov Nk-32-02 afterburning turbofan engines, aiming to surpass the performance of the original Nk-32 engines. The Tu-160M is also slated to be armed with advanced weaponry, such as the KH-BD missile, which exceeds the capabilities and range of its predecessor, the KH-101. With an anticipated range of up to 8,000 kilometers, the XBD missile equips the Tu-160M with the ability to outmaneuver and deceive enemy air defense systems effectively. This capability enables strategic flexibility, exemplified by scenarios where bombers could launch missiles from distant locations like Caracas and safely reposition elsewhere, as demonstrated in previous missions to Venezuela. Despite its primary base in Engels, Saratov region, the Tu-160M's operational range extends globally, facilitated by mid-air refueling capabilities. With a practical flight range of around 12,000 kilometers and the ability to remain airborne for over a day when refueled, these bombers can rapidly deploy to distant theaters of operation. This was showcased in 2010 when a Tu-160 recorded a range of 18,000 kilometers, highlighting its expeditionary potential in strategic contexts. Under a contract signed in 2018, 10 of the modernized Tu-160M nuclear bombers are meant to be delivered to the Russian Air Force up to 2027 at a cost of 15 billion rubles, $163 million, each. Russia plans to eventually buy about 50 Tu-160M bombers and is upgrading 16 existing Tu-160s to the standard, with the first Tu-160M set to be delivered imminently. Series production is to begin by 2023 at a production rate of at least 3 aircraft a year. This would fit with the order for 10 aircraft in the 2023 to 27 timeframe. The Tu-160M upgrade is being rolled out in 2 phases, with the first Tu-160M1 phase comprising the new K-042K-1 navigation system and ABSU 200-1 autopilot, as well as the removal of some previous systems, such as bomb sighting systems. This Tu-160M1 variant has been operational with the Air Force since late 2014. The second Tu-160M2 phase includes the new Novella NV-1.70 radar, a digital, glass, cockpit, modern communications, and anti-jamming equipment, upgraded NK-32 engines, designated NK-32-02, and modern conventional and nuclear weapons. The aircraft is also expected to carry the latest Russian-made hypersonic weapons. According to Rigmont, several missile launches would need to first successfully hit targets at the Sari-Shagan test range in Kazakhstan or the Pemboy test range in the Arctic region. The modernization efforts undertaken for the Tu-160 demonstrate Russia's commitment to maintaining a formidable strategic bomber capability. Through the integration of advanced avionics, stealth technology, improved engines, and enhanced weapon systems, the Tu-160 has been transformed into a more capable and versatile platform. These upgrades ensure that the aircraft remains relevant in an evolving security landscape, allowing Russia to project power, deter potential adversaries, and protect its national interests.